SDLC is the traditional process used to develop information system and application. The information technology industry developed the SDLC in the School of Hard Knocks. Many early projects met with disaster, and companies and system developers shift around the ashes of those disasters to determine what went wrong. By late 1970s, most seasoned project managers agreed on the basic tasks that need to be performed to successfully build and maintain information system. Different authors and organizations package the task into different number of phases. In this book, we will use the following 5-phase process. 1. Define system. 2. Determine requirement. 3. Design system component. 4. Implement system. And 5. Maintain system. Figure 10.9 shows how these phases are related. Development begins when a business planning process identifies a need for a new system. This need may come from a BPM design activity, or it might come from some other business planning process. Developer in the first SDLC phase system definition use management statement of the system needs in order to begin to define the new system. The resulting project plan is the input to the second phase, requirement analysis. Here, development identify the particular features and function of the new system. The output of this phase is a set of approved user requirements, which become the primary input used to design system component. In phase 4, developer implement, test, and install the new system. Over time, user will find errors, mistake, and problem. They will also develop new requirement. The description of the fixes and new requirement is input into a system maintenance phase. The maintenance phase starts the process all over again, which is why the process is considered a cycle. In the following section, we will consider each phase of the SDLC in more detail. Define the system. In response to the need for the new system, the organization will assign a new employees, probably on a part-time basis, to define the new system, assess its feasibility, and plan the project. In large organization, someone from information system department lead the initial team, but the member of the initial team are both user and information system professional. For small organization and for startup, the team will be led by an outsider consultant. Define system goal and scope. Figure 10.10 shows the first step is to define the goal and scope of the new information system. Information system exists to facilitate an organization's competitive strategy by supporting business processes or by improving decision making. At this step, the development team defines the goal and purpose of the new system in terms of this reason. The scope might be defined by specifying the user or the business processes or the plant, offices, and factories that will be involved. Access feasibility. This step answers the question, does this project make sense? The aim here is to eliminate obviously nonsensical projects before forming a project development team and investing significant labor. Feasibility has 4 dimensions: cost, schedule, technical, and organization. Because information system development projects are difficult to budget and schedule, cost and budget schedule feasibility can only an approximate. Back to the envelope analysis. The purpose is to eliminate any obviously infeasible ideas as soon as possible. Cost feasibility involves an assessment of the cost of the project. Clearly, it depends on the scope of the project. At this point, all the team can do is to make rough estimates, like cost feasibility. Schedule feasibility is difficult to determine because it is hard to estimate the time it will take to build the system. At this stage of the project, the organization should not rely on either cost or schedule estimate. The purpose of this estimate is simply to rule out any obviously unacceptable project. Technical feasibility refers to whether existing information technology is likely to be able to meet the needs of the new system. Finally, organizational feasibility concerns whether the new system fits within the organization custom, culture, charter, or legal requirement. If the defined project is determined to be feasible, the next step is to form the project team. Normally, the team consists of both information system professional and user representative. The project manager and information system professional can be in-house personnel or outside contractor. Typical personnel on a development team are a manager for managers or managers for larger projects, business analysis, system analysts, programmer, software tester, and users. System analysts are closer to information technology and are a bit more technical. As stated, there is considerably overlap in the duties and responsibilities of business and system analysts. Both are active throughout the system development process and play a key role in moving the project through it. Business analysts work more with managers and executives. System analysts integrate the work of programmer, tester, and user. Depending on the nature of the project, the team may also include hardware and communication specialists, database designer, and administrator, and other information technology specialists. The team composition changes over time. During requirement definition, the team will be heavy with business and system analysts. During design and implementation, it will be heavy with programmer, tester, and database designer. During integrated testing and conversion, the team will augment it with tester and business users. User involvement is critical throughout the system development process. Depending on the size and nature of the project, users are assigned to the project either full or part-time. Sometimes users are assigned to review and oversight committees that meet periodically, especially at the completion of project phase or other milestone. Users are involved in many different ways. The important is for the user to have active involvement and to take ownership of the project throughout the entire development process. Determine requirement. Determining the system requirement is the most important phase in the system development process. If the requirements are wrong, the system will be wrong. If the requirements are determined completely and correctly, then design and implementation will be easier and more likely to result in success. Examples of requirements are the content and the format of web pages and the function of button on those pages, or the structure and content of a report, or the field and menu choices in a data entry form. Requirement includes not only what is to be produced, but also how frequently and how fast it is to be done. Some requirements specify the volume of data to be stored and purchased. Typically, system analysts interview users and record the result in some consistent manner. As listed in Figure 10.11, sources of requirement include existing system as well as the web pages, form, report, queries, and application feature and function desired in the new system. Security is another important category of requirement. If new system involve a new database or substantial changes to an existing database, then the development team will create a data model. That model must reflect the user perspective on their business and business activities. Thus, the data model is constructed on the basis of user interview and must be validated by those users. Sometimes, the requirement is so focused on the software and data component that other components are forgotten. Experienced project manager ensure consideration of requirement for all 5 information system components, not just software and data. Regarding hardware, the team might ask, are there any special needs or restrictions on hardware? Is there an organizational standard governing what kind of hardware may or may not be used? Must the new system use existing hardware? What requirements are there that communication and network hardware? Similarly, the team should consider requirements for procedure and personnel. For example, do accounting control require procedures that separate duties and authorities? Are there restrictions that some action can be taken only by certain department or specific personnel? Are there policy requirements or union rules that restrict activities to certain categories of employees? Will the system need to interface with information system from other companies and organizations? In short, requirements for all components of the new information system need to be considered. These questions are examples of the kind of questions that must be asked and answered during requirement analysis. Because requirements are difficult to specify, building a working prototype can be quite beneficial. As they work with prototype, users will access usability and remember features and functions they have forgotten to mention. Additionally, prototype provide evidence to assess the system technical and organizational feasibility. Further, prototype create data that can be used to estimate both development and operational costs. To be useful, a prototype needs to work. Mock-up of a form and report, while helpful, will not generate the benefit just described. The prototype needs to put the user into the experience of employing the system to do his or her task. Prototype can be expensive to create. However, this expense is often justified not only for the greater clarity and completeness of requirement, but also because part of the prototype can often be reused in the operational system. Unfortunately, system developers face a dilemma when funding prototype. The cost of the prototype occurs early in the process, sometimes well before full project funding is available. A common complaint is, we need the prototype to get the fund, and we need the fund to get the prototype. Unfortunately, no uniform solution to this dilemma exists, except applying experience guided by intuition. Once the requirements have been specified, the user must review and approve them before the project continues. The earliest and cheapest time to alter the information system is in the requirement phase. Changing a requirement at this stage is simply a matter of changing a description. Changing requirement in the implementation phase may require weeks of reworking application component and the database structure. Each of the 5 components is designed in this stage. Typically, the term design is component by developing alternative, evaluating each of those alternatives against the requirement, and then selecting from among those alternatives. Accurate requirements are critical here. If they are incomplete or wrong, then they will be poor guides for evaluation. Figure 10.12 shows that design tasks pertain to each of 5 information components. For hardware, the team determines specification for what the system will need. Program design depends on the source of the program. For off-the-shelf software, the team must determine candidate product and evaluate them against the requirement. For off-the-shelf with alteration program, the team identifies product to be acquired off the shelf and then determine the alteration required. For custom developed program, the team produces design documentation for writing program code. If the project includes constructing a database, then during this phase, database designer convert the data model into a database design using techniques such as those described in Chapter 5. If the project involves off-the-shelf program, then little database design needs to be done. The program will have been coded to work with pre-existing database design. Procedure design differs depending on whether the project is part of a BPM process or part of a system development process. If the former, then business processes will already be designed, and all that is needed is to create procedures for using the application. If the latter, then procedure for using the system need to be developed, and it is possible that business processes that surround the system will be needed as well. With regard to people, design involves developing job description for the various roles. This description will detail responsibilities, skill needed, training required, and so forth. The term implementation has 2 meanings for us. It could mean to implement the information system component only, or it could mean to implement the information system and the business processes that use the system. Developers construct each of the components independently. They obtain, install, and test hardware. They license and install off-the-shelf program. They write adaptation and custom program as necessary. They construct a database and fill it with data. They document, review, and test procedures, and they create training program. Finally, the organization hires and trains needed personnel. Once each component has been tested independently, the entire system is tested as an integrated whole. Testing is important, time-consuming, and expensive. A test plan is written. A test plan is a formal description of the system response to use and misuse scenario. Professional test engineer called Product Quality Assurance or PQA test engineer are hired for this task. Often, teams of these engineers are augmented by users as well. Once the system has passed testing, the organization installs the new system. The term system conversion is often used for this activity because it implies the process of converting business activity from old system to the new. 4 types of conversion is possible. 1. Pilot, 2. Phase, 3. Parallel, and 4. Plum. With pilot installation, the organization implements the entire system or business processes on a limited portion of the business. An example would be for Pride to use the new system for just a few patients. The advantage of pilot implementation is that if the system falls, the failure is contained within a limited boundary. With phase installation, the new system or business processes are installed in phases across the organization. Once a given piece works, then the organization installs and tests another piece of the system until the entire system has been installed. Some systems are also highly integrated that they cannot be installed in phase pieces. Such system must be installed using one of the other techniques. With parallel installation, the new system or business processes run parallel with the old one until the new system is tested and fully operational. Parallel installation is expensive because the organization incurs costs of running both the existing and the new system. User must work double time, if you will, to run both systems. Then considerable work is needed to reconcile the result of the new and the old system. With Plum installation, sometimes called direct installation, the organization shut off the old system and start the new one. If the new system falls, the organization is in trouble. Nothing can be done until either the new system are fixed or the old one reinstalled. Because of the risk, organizations should avoid this conversion style if possible. The one exception is if the new system is providing a new capability that will not disrupt the operation of the organization if it falls. Figure 10.14 summarizes the tasks for each of the 5 components during the design and implementation phases. With regard to information system, maintenance is a misnomer. The work done during this phase is either to fix the system so that it works correctly or adapt it to changes in requirement. Figure 10.15 shows tasks during the maintenance phase. First, there needs to be a means for tracking both failure and requests to enhancement to meet new requirements. For small systems, organization can track value and enhancement using word processing document. A system becomes larger, however, and as the number of value and enhancement requests increases, many organizations find it necessary to develop a tracking database. Such a database contains a description of the value or enhancement. It also records who reported the problem, who will make the fix or enhancement, what the status of the work is, and whether the fix or enhancement has been tested and verified by the originator. Typically, information system personnel prioritize system problem use according to their severity. They fix the higher priority item as soon as possible, and they fix low priority item as time and resources become available. Because enhancement is an adaptation to new requirement, developers usually prioritize enhancement requests separate from value. The decision to make an enhancement include a business decision that the enhancement will generate an acceptable rate of return. SDLC projects are difficult to manage. There are 5 keys to success. 1. Create a work breakdown structure. 2. Estimate time and cost. 3. Create a project plan. 4. Adjust the plan via trade-off. And 5. Manage development challenges. 1. Create a work breakdown structure. The key strategy for SDLC project is to divide and conquer. Most such projects are too large, too complicated, and the duration too long to attempt to manage them as one piece. Successful project managers break the project smaller and smaller tasks until each task is small enough to estimate and to manage. Every task should culminate in one or more results called deliverables. Examples of deliverables are document, design, prototypes, data model, database design, working data entry screen, and the like. Without a defined deliverables, it is impossible to know if the task was accomplished.